So here's the finding the area question that we finished off with. So basically we've got to find the shaded area, and the way we do that is that we need to basically find the integral of sine 2x minus sine of x cos squared x dx. Okay. So let's take them separately, because obviously we can basically just do this and split them into two different integrals. So the first one, so we've got sine of 2x dx. Well, okay, that's pretty simple. We know that if we integrate sine, we get minus cos of 2x. And because we have an a, something multiplying our x, that means we have to divide by that. So we've got minus 1/2 cos 2x. Okay, now we do the integral of sine x cos squared x dx. So as we noted, this looks like it's an integral of f of x times its derivative. So what do we do? So basically we said that for this form, what we'll do is we'll guess that it's our function with 1 added to the power. So when we differentiate this, it equals 3 cos squared x times sine x, and that's going to be a minus. So that's what our derivative should look like. Right, so now we take our derivative and we compare it to the thing that we're trying to integrate. And you can see that the only difference is that it's the minus 3, and we haven't got a minus 3 here. So our guess is not quite correct. What it should be is minus a third cos cubed x. Okay, and then if we differentiate minus a third cos 3x, we would get sine cos squared x. So now we've got our two integrals. So we can write that this is equal to minus a half cos of 2x plus, because remember, basically we should be subtracting, we're subtracting a negative, so that gives us 1/3 cos cubed of x. Okay, and then we have to do is put our limits in. So our limits is going from 0 to pi over 2. So that means that we've got pi over 2 to 0. Okay, so now we've got our integral. What do we say? We'll go to brackets. So I've got one bracket minus the other bracket. I'm going to substitute pi over 2 into the first one. So I've got minus 1/2 of cos 2x. Well, x is pi over 2, so that's just pi. And then I'm adding 1/3 of cos cubed pi over 2. Okay, because that is just 1/3 is cos cubed of x, not 2x. So then we do the same thing on the other side with 0. So we've got minus a half cos of 2x, x is 0 here, plus 1/3 of cos cubed of x, which is 0. So what does that give us? So 1/3 cos cubed of pi over 2, well, that's just 0. Cos of pi is a half. Oh, sorry, cos pi of 1, sorry. Cos pi is 1. Cos of 0 is 1. Oh, sorry, minus 1. Cos of 0 is 1. So now we can start to do this. So that means that we've got on the left-hand side, minus a half times 1. That's a half. This is 0, so there's nothing here. In the other bracket, I've got minus a half times minus 1. So that is the minus a half. And I've got 1/3 times 1. I've got 1/3. Okay, and then that means I've got a half minus negative a half, so plus a half. And then I'm taking away a third. Well, 2 halves make a whole. Take away a third. 2/3. And that is our final answer. Okay, so when you think about writing this out, make sure you've got the integral written out. Here's our answer in brackets with limits. Then 2 separate brackets where we substitute in the values. If we've got trig functions, then we can basically work out what the values of trig functions are. Lots of exam questions use nice round numbers, or at least fractions that are easy to combine. Then I've got the fractions, and then we get to our final answer. I hope that's useful.